Welcome to Rubber Duck Engineering. Tonight, we're going to write an HTML parser in Dart. Something that Dr. Barth and I have done, well, maybe like a decade ago, and it wasn't in Dart. But hi, Dr. Barth.
Hey, Eric. But that was HTML5. Tonight, it's HTML6.
It's true. Tonight, we are going to new places. So yeah, we were bantering around what we were going to do before the start of the day or the start of the show, and you suggested this, and it sounds like a lot of fun to me. I really enjoyed writing HTML5 parser back when it had not been done before. We did it
when the Firefox folks had done it too. Just
yeah, I was
early on in that thing.
I was amused. We went looking to see if this had been done in Dart, and I was amused. There is one. It's a port of HTML5 lib, which somehow then, when we went to the license, was attributed to us, which I guess we contributed to. I don't know.
I think we contributed to the test suite because I think that HTML5 lib was where the centralized parsing test suite was.
Yes, we definitely contributed to the test suite as we tried to make it work.
Hi, Nash. Thanks for joining us. Hi, Stack. Yeah, we're doing great. I'm glad you can come back. Welcome.
Yeah. So we thought about the idea of writing in Rust, decided that a DOM tree and Rust were not going to get along. And so we decided to try Dart. And we're starting from a blank slate.
Should we dive in? Let's just start.
Yeah, we're going to go look at the spec here. Before I do that, I would just want to show you what we're going to implement.
Hi, Heshman. Thanks for joining us.
Swapping windows is hard in my setup. So I just typed HTML5 spec. We're going to start from HTML5 and evolve. And you just go, it's the same as it was a decade ago. You go to the HTML5 spec.
Do not click the one-page version button. That will destroy your browser as it tries to load a huge amount of stuff into it.
It's really nice for searchability, or it was. We probably want this, HTML5 syntax. Yeah, this is it. And then parsing HTML5 document, 13.2.
Yep. We probably need to start with just the DOM, so we have something to parse into.
Okay. But anyway, so if you want to follow along at home, we're just looking at this doc, which again has probably changed in a decade. But so let me pull up the actual. All right, so this is what we started from. And I said this is literally just a Dart create. We did Dart create console full. That's it.
Calculate.
So you said you wanted to start with a DOM. So being able to build a tree.
We need like a node.
Mm-hmm.
The
node was actually, it was an interface. It was like a node parent, node children. This is like a list or an iterable.
Well, I think we just want first. I think we just do first child, right? First child,
okay.
Last child, because it ends up being a doubly linked list, right?
Yeah.
Then do nodes have siblings? They must, right?
Yeah. Next sibling or something like that.
Good sibling.
Mm-hmm. That sounds right.
Can be nullable, right? Everything can be nullable.
Mm-hmm. Yep.
Okay.
We're doing this from memory. We could go look at the spec, but
seems fair to do from memory. So then it's got to be like a pen child.
Mm-hmm.
So this is like we try to write this out.
I remember when we did this, we had like a parser append child that like sidetracked all the steps.
Yeah, that was a performance optimization. We may come back to do that if we look at performance, but I think we should maybe just start with the basic.
Well, we're not actually like implementing a DOM interface. We don't need to throw the right exception or whatever on append child.
That's true. But we do want to do things like if node.parent is not null. Then we need to remove the node from its previous parent. And then we need to add it to us. So node parent this. And then child. If we don't have a first child, then this node is now our first child. And then in all cases, we need to remember the original last child. Last child. And the last child is going to become the node that we're inserting at the end. And then if there was a last child before, then node's previous sibling is now the original last child. Original last child's next sibling is now the node. I guess we could all just do this beforehand. We don't need this temporary. Why is this mad? Right, so here we want to call node.parent.remove child node, right? So how do we implement that? So first of all, we should say if node.parent equals this, we need to throw an exception.
Is there a way to do this way, or am I thinking of Rust?
I don't know. Is there? You're trying to get rid of the nullability thing? Yeah, I don't know. Probably. Okay, so we want to say previous sibling equals next sibling. Pull out node.parent. Now we need to remove it from the linked list of children. So what's the way to do that? If node.firstChild equals node, now first child is node.next sibling. If node.lastChild equals node previous sibling. Now we actually need to remove it from the list. So we want to say roughly node.previous sibling dot next sibling, which would normally be node, is now node.next sibling, and node.next sibling. Previous child is now node.previous sibling. Okay. And then we need to null out these things. Okay. And now we need to write some tests. There's a chance that we wrote all this list manipulation correctly on the first go. It's basically non-existent.
I have faith. All right, so let's see. What is it crying about here? What is it sad about? Calculate is fine. Get that. Body might complete normally, causing null to be returned. Oh, do we not return the removed thing?
You want to return the argument that you passed in. Okay. All right. We can look at this back to see what the right is.
Is there a way that this exit? Oh, I see. Throw. Okay. Calculate. Yep. Unused import. Yeah, we'll get to that. All right. So as you said, we should use it. We should write a test.
Yeah.
So we want to write a test that we add and then it's parent. So we do
I think to write the test, we may want to write a function that dumps the tree, just so we can make an easy test picture.
Like YAMLing it or something, or like how do you want it to represent?
I guess we don't have any names for these things, so maybe maybe just write a basic test first.
All right, so basic. You want to just make a node, right? Var node is equal to node. Right, so expect node.parent is null. Right, that's true. And var other is equal to node. Right, and then we do.
I'm going to put all these fields here for reference so we can know all the things we're supposed to check. Well, I'll just spam out checks for all of them.
Great. Node dot append child other. I guess we'll call this child. Okay, we want. Great.
Equals, right?
I'm changing them to child.
Oh, we need to assert both on the parent. We rename this the parent.
I did these for child. We can add the. Oh, yeah, good idea.
Oh, vertical editing. It's the best thing ever. Oops.
All right. Yeah, parent's still null. Child is now parent. Yep. First child is still null. These should all still be true. We actually are going to want this to, we want like a child 2, basically. Child 2.
You want to append child 2?
Yeah.
Okay.
I don't know if we really want to test this all again, but sure. Okay, child 1 and child 2.
So now the last child is child
vertical
2.
editing magic.
I'm going to vertically edit this.
I just did. Okay, I see you named it child 1. Fine. Okay.
Oh, I should rename this child 1.
All right, so next sibling is now going to be child 2. Previous sibling is still null. This is going to be child 1.
Yep. And then we should have parent 2, so that we can like remove and adopt correctly. We'll say parent 2, append child, child 1. And then these facts should be.
This is going to be writing a lot of tests at first.
Yeah, otherwise you're just going to get yourself super confused if you try to like build from a rotten foundation.
Yeah.
The list manipulation stuff is so easy to get wrong. Okay.
Oh yeah, you just miss one little bit and then you start leaking or something. Yeah. You get yourself a lot of trouble.
What does parent 1 look like after we do this? Parent 1, its first child should just be child 2 now. And what does child 2 look like after we do this? Child 2's parent should still be parent.
I bet we didn't fix up the siblings.
Well, we're going to find out. Great, should we try this? Try running this test?
Okay. All right, let's see what happens. Got to get to the terminal. We want start test, I think. Magically run that test. Yeah, so you stopped working on the project since this happened, but there is now a Dart command that basically does almost exactly what the Flutter command does.
Oh, cool. Yeah, I think these multi-command tools are super useful.
Yeah.
How far do we get?
we got?
Line 22. Got that? That's like the third test. Okay. That looks legit, so maybe our code is wrong. A first child is not.
Yeah.
Let's try that.
Mm-hmm.
That we can actually, there's just a fancy way of writing that, right? That's just question mark equal.
Yep.
Is it double question mark equal? Yeah.
But this is case in point, right? If you haven't written that test, you're off in super confused land. All right, this is 2012. Null check operator used on null value. This is 17.
And 17.
Oh.
Oh, if last child equals null. Oh. Maybe this one was right.
No. Weird.
No, HTML6 not a thing. That's the joke.
Hence the Galaxy Brain. Yes, it's not a thing. At least not to my knowledge. Maybe there's an HTML6 spec. I don't know.
Testing for the win. It's more like testing for the crawl. Like we haven't won yet.
What do we got here? Expected.
Oh, we got
different...
line 63.
That's significantly further.
We didn't fix up the first and last child in the removal step. Okay, I believe that. Yes. If node, the first child, was node, now the first child. Oh, no. If my first child was node. Okay. There's no way to write these things correctly. Like I can't tell you how many times I've written the doubly linked tree. You just can't do it. Like it's just too many pointers. Like
there you go.
Just pass. Great.
Okay. We're gonna need a name. These nodes are gonna need a name, or maybe element has a name.
Element has a name. So the last thing we need to do
node has a
is
node name.
We need to make sure you don't add yourself as a child of yourself.
Sure. Like ever?
Yeah, you don't want the trees to have like cycles in them.
Okay.
So I think you just need to check here.
That, like half of a pen child was all just error handling.
Yeah, I think if node is equal to this, I just think we need to throw an exception.
An episode dedicated to the Dart debugger.
Okay.
Sure. I don't actually know the Dart debugger very well.
Well, we may get into it in this if we like mess up.
There's a YouTube talk about the Dart debugger from the Dart Summit, like 5 years ago in Munich, by actual Dart debugger engineers.
I'm running a new test for appending to yourself.
Okay. Are you just doing one layer, or are you?
I think that's enough.
Well, I'm sure that in the. I mean, don't you have to like walk to make sure there's no cycles or something like that? Just walk up your parent tree and make sure you don't find yourself, or I don't know what the algorithm is here.
I mean, that sounds plausible. Do you want to try to write a test case that shows that?
I mean, a test case is very straightforward, right? You just write our child. What's going on? Oh, I see. Okay, fine. Var parent is equal to node, right? And then you just do var parent append child.
Mm-hmm.
Right, and then you do expect child dot append child dot parent, right?
Yep.
Should be throws.
Okay.
What did I do wrong here?
Well, you just need a semicolon.
I put a var, an extra var. That was my problem.
Yeah, so I bet this test will not pass.
Yeah, I expect it won't.
That's right. So we need to write rule is descendant of.
I wonder how they do this to make this not O of n append.
This is part of what the parser append child thing optimizes.
Because it doesn't need to do this.
Yeah, there are all these special invariants, like it has to be a newly created child, and so it skips a lot of these error checks.
The reason why I say O of n is like we're about to do a walk up the tree, and that just means like why do you need to be O of the depth of the tree when you do an append? And that's actually then sad because it just means that DOM manipulations from JavaScript can never be
It's fast, yeah.
In fact, well, the way you do it is just to build up the subtree and then insert an entire subtree to make it the depth of the tree. You have to keep the tree depth low. Oh, I think is descendant of might actually be. I have the MDC docs up just to see what the actual.
So if child
insert before. Let's get node.
It's descendant of this. And return that. Okay. Should we try the test? Did we get it?
Parent element. Wow, all this stuff. Sure, let's try. I want to learn how to use this fancy, like, does this work? Whoa, activating extensions. What does that mean? Build errors exist and show errors. Calculate isn't defined.
I agree.
Okay. I agree.
This is the template code.
So you're saying that I'm not allowed to run my tests if the build errors exist? I'm trying to be a little fancy and learn how this tool works. Which I think is actually really important for me in discovering a system is like to just try things every once in a while and not just fall into my rut. Okay, throws instant of exception, actual closure through invalid argument.
Oh, we need to throw an actual exception. We just threw a string through.
Oh, okay.
Exception. And it sort of wasn't legit just to like throw a whole string. Okay.
All right. Okay. I think there's also a testing window here. I feel like I've seen that. Yeah, this.
Oh, will it like auto run your test constantly?
I don't know. Probably there's some way to do it.
Well, both tests are called basic. Maybe we need to name one of them. Like, version disallowed. Circles disallowed.
Okay. I have no idea what. Oh, here we go.
Oh, is it going to get the green dot?
Well, I just clicked the run thing.
Green
Great.
dot. Nailed
Green
it. Okay, elements.
Elements. So why do we need to separate?
That's how it is in HTML5. In HTML6, it could be the same. It's because
we're not going to have header nodes in our HTML6, so.
Yeah, but we'll have text nodes, right?
Okay.
Text nodes are not elements.
Yeah, okay, fine.
Okay, element has a tag name. We're not going to do qualified names, though. We're just going to do basic tag names. To do.
No, why would you ever need qualified names? We're not having namespaces. I'm sorry.
Okay, HTML6, no qualified names.
We have single flat namespace.
You have element, get, first, element child, element. last element on
like.
center element. And then we have attributes, right? So we have a map string to string, which is
Oh, okay, it's true. I don't know that we're gonna get to attributes tonight, but sure.
the element needs to.
Like, I'd be happy if we go look at what the HTML5 test suite looks like, but
I guess we probably don't need these guys for now. Okay. What else is an element? Seems legit, right?
what is?
So this definition of an element.
Yeah. I'm looking for
We have set header.
the tests.
String. Okay. Here. Here.
Aha. HTML5 lib tests. Brings back memories, man.
Okay.
Wow, this stuff is all crazy with doc types and stuff.
Oh, we need a doc type.
No.
Yeah.
Really? Why? But then you need the stupid less than bang syntax.
Yeah. I mean, that's how it goes. So we got a doc type. We need a comment, right? A comment node.
But I thought this was HTML6. Where we ascend past.
Text node.
I think they just call it text, yeah.
Let's add a string. It's called text content, I believe it's called. Also can't be null. Okay. What other kind of nodes do we need? That's right enough for now.
Entity
Right?
nodes? Are entity nodes a thing? No, the parser just turns.
The parser just turns those into text.
Yeah, that was a bad idea that HTML5 fixed. I'll just look with your tests here real quick. Okay.
Should we start with the parser? So
Yeah,
we're
I
going
think that's the exciting part is getting to the parser.
There we go. Done.
Yeah, and just return a node. Let's wire it up.
It's one of the interesting things is this thing should never throw an exception. It's always every string of text in HTML will parse into a document.
Okay.
Like this is a first approximation to so would you write a test that fails?
Well, yeah, okay, sure. Write a test that fails. I see that it doesn't. Okay, sure. Yeah, we're not. I don't think we're going to like harness test basic parse. Okay, and then did I do this right? I never know how to write these from scratch. I just have to like copy one. I think that's right. Yeah. We want to.
We could actually write a test that passes.
Our doc equals parse. We want to just do what? Body.
Well, I mean, the simpler one is just b equals parse the empty string. That one will actually pass.
Okay.
We could say like expect b dot first child is null, etc.
What if it's a space? Should you get a text node?
Yeah, let's write that test.
A. I can't remember if there's an implicit body in HTML5. I think there was.
Well, let's write separate test cases for this. So this is parts empty. Let's write parts space.
Or hello world or something like that.
Well, parts space is going to end up being different from like parts hello.
Because you want a line white space?
Because of the way the tag generation works, the implicit tags that you get from we'll see this once we start writing the parser. Like you'll get more elements. Like you'll get a body here, but you won't get a body here.
Okay.
You'll get an HTML tag here, I think. I'm not sure. I don't remember.
I don't remember either. I go find those tests.
Oh, yeah. We'll just start with these. So we don't know how to write our expect statements yet. Like, I think we're going to want some way of dumping a document into a string. So I don't know if we want to write that first, or we want to start with the parser first.
I'm just looking to see what. I'm just looking to see what the test, how they write them. Okay,
Do you want to show us your browser? I remember they had a like nice way of doing this.
I'm playing it on the Firefox gentleman's name, who I think wrote so much of this.
It was Henry, right?
Yes, Henry. So, yeah. So this is what I remember.
Yeah, we should write this thing.
Test format. Why? I don't know. I actually don't know the time right now, but I don't know that we have time tonight. Oh, yeah, we have about half an hour.
So I think they had ones for the Lexer, which was simpler.
Those appear to have changed. So this is all the tree construction tests. But if we look at the tokenizer tests, these are all different now. They're now JSON, which is fine. But I think these also were that same style back in the day. Right, so input. So what is this?
So I think it gives you one doc type token that has those, whatever, 6 fields in it.
Yeah, I see. This is the token stream. What's null?
I think it can have like a system field, and like it has the doc type node or token has a few more fields in it. Yeah, these look sort of sensible. So
I think writing this harness and stuff, that's going to be a non-zero amount. We could do that now, but
I think maybe we should just start with the tokenizer, which will force us to write a bunch of token objects. And then I suspect that once we have the token objects, creating these outputs from them will be relatively straightforward.
Sure, I agree. So you don't want to continue down the parse, which makes sense. So we're backing up and going into tokenizer land now.
Yeah, so I think maybe we should look at the spec and start the tokenizer.
Okay, so that's here.
So just sorry, we're jumping ahead because we're sort of familiar with this. The way HTML parsing works is there's sort of 2 phases to it. So the first is you process the text input and you break it up into chunks called tokens. And then you feed those to a thing called the tree builder, which then builds an actual DOM tree out of those tokens. And then there's a super weird thing in HTML where the tree construction feeds back into the tokenizer because HTML is crazy. So you basically need to do, the way we actually did it in the real parser is we ran a little pretend tree builder during tokenization so that we can have the tokenization phase be totally separate from the tree construction phase. But I suspect the way that we'll do it here is we'll have the real tree builder feedback into the real tokenizer, because it's way simpler than the way we did it the real way.
Yeah, so I remember this, and then this whole crazy thing about like figuring out what encoding you're in.
Yeah, we just skip all that because we're already in a string, so we're just going to be already encoded.
Character encoding, yada yada yada, yeah. So this is looking for.
This is still trying to determine the encoding.
Changing encoding to parsing, pre-processing the input stream. Okay, so this is removing.
There's another thing that browsers do is they scan ahead in your document to try to discover all of your sub-resources.
Oh, the insertion mode. Some are
this is for the tree builder.
Reset. This is like when you document.write, you reset your insertion mode, right?
Yep.
Okay, yep. Stack Overflow. This is all True Builder stuff.
I think the tokenizer must be earlier.
Maybe.
Tokenization. Yeah. There we go. The data state.
Yes. Yeah. Oh man.
Yeah. This is where we are.
I remember this was a lot of typing.
Yeah.
Massive switch statement.
We're not going to get it all in this episode, but we can at least start.
Mm-hmm.
So we're going to need.
Well, I do think we need to think a little bit here. So how are we going to? I remember in C++ we represented this as a massive switch statement with a bunch of macros and stuff, and I could see doing something like that in Rust. I'm less confident as to how we're going to do this. All this jumping around in Dart.
Oh, let's try it and figure it out.
Okay, sure. Let's just try and figure it out.
So we're going to need an input manager.
Mm-hmm.
Do you want to show the place we're typing to the viewers?
Oh yeah, sorry. I need a fancier camera setup here. And by camera setup, I mean Windows setup.
So what the input manager is going to do is basically keep track of where we are in the input stream. So the input manager is going to have the data stream, and it's going to have, just to start with, we'll have the next offset. And it gets complicated because HTML can go backwards.
Mm-hmm.
That's fine.
Okay, it tracks the insertion point and the next input character.
Yes. So then let's have a function called string get next character. It's going to return the next offsets.
It's asked, will HTML6 be backwards compatible? And I would say, of course, it'll be perfectly backwards compatible. Every single website will work. I hope you hear the sarcasm in my voice. We're just having fun here.
HTML6 is our license to maybe not do qualified names or some parts that we don't want to do.
Like
okay, so we've got next character. So then we need like a, we don't know when it's going to return yet. So let's say void tokenize token. I don't know what it's going to return here. It's going to return a token, I guess. That next token. We don't know what a token is yet. Okay.
Mm-hmm. Yep.
So we need to know. You know, I'm going to pull this off just because I've done this before. I'm going to make a tokenizer class.
Yes, correct. That takes the input stream and
the input manager is going to be a member.
Yep.
Okay.
This is very similar to what we did for the ren, right? We've done one of these before.
Yes. Okay. So now it's also going to have a state, which is the, what do they call it?
The parse state? No. Insertion mode?
Insertion mode is what the tree builder has. Anyway, it has a state. And then we're going to have to switch.
Or like data state versus.
Yeah. I do like an enum for the tokenizer state. So data state is the first state.
Mm-hmm.
Showcase tokenizer state data. Okay, and then I need to write some code.
Mm-hmm.
And then why is this mad? Non-nullable state. No. I think we started the data state. If I remember correctly.
That sounds about right. Let's see. I'm reading the spec. State machine must start in the data state. Most states consume a single character, which may have various side effects, and either switches the state machine to a new state to reconsume the current input.
So let's just write a very basic version of this. Input get next character. Okay. If this has to be, I can set these brackets there. So if character is null, then return EOF. Okay.
Yeah, I'm reading a spec. If it's null and you're in the data space, this is an unexpected null character parse error. Return the current input character as a character token. I remember, in fact, doing this because we would do things like we would write parse error here.
Right.
Unexpected null character.
Yes, we will revolutionize the web in a 1 hour stream. You're exactly right.
And then I remember that like
these functions did nothing. We just
error, was just this like the entire time. And so it was all just like imagining one day that someday somebody might want to make the errors work.
But they were in the spec, so we wanted to write them. I think we can let's align them in this one.
You may actually need to wire up the error handling to pass some of the things, but we can ignore that. I don't know how much of the HTML5 or HTML6, please, spec we choose to pass here. So this is going to be token.eof or IC. It's just okay. That works.
I don't know. Let's start with something simple. And we're going to need to make a text token here, right? Like there's a
character token, you mean?
Character token, yes. But we're supposed to collect them all. Do we emit them individually?
In this case, you emit the current input character as the character token.
As a single character token?
In a null case, yes. That's if you have a null. So this is like just your...
Oh, right. So
this is not actual EOF. Right? Remember, I think we synthesized an EOF character in the token stream. Maybe we did that for Ren.
String buffer is a thing, right? And we need to... But I think this needs to return an iterable token, right?
For get next token? I don't know if get next token is the... We have to look at the spec, but I see. Okay, sure.
No?
Let me try
Maybe
that
a single token? I'm not sure whether we're going to have to return more than one. But like, what's going to happen here is we can say, if we hit the end of the thing, if the text buffer is not empty, then we're going to need to return a character token.
I think the way you're going to actually not end up doing it that way so much as you're going to do like void emit. Like I think those may end up being special or something like that. I don't know.
Oh,
I don't know that you want to do it in this draw form.
Okay.
I don't know. I think we just try. As you said, I think we just try. We're not gonna, as someone said, we're not gonna revolutionize the web in a single 1 hour stream. The interesting thing about the web is that like what we're doing here, evolving is just not possible. The web always has to be backwards compatible. So that was the amazing thing about HTML5 is that somebody wrote down a way that you could actually write a backwards compatible thing. It gave a sane framework to build from.
So then this is like append star here.
Maybe it's probably push or something.
Add in.
String buffer Dart. String buffers in Dart core. And it is right. No, that writes. Right. Yeah, right. Wow, crazy. Creates a string buffer with the initial content. Pause for okay.
This is while input is.
That's wild. Okay.
We we have our HTML file, I'll do all this.
Yeah, I think you're gonna end up. I think you're gonna end up rewriting this part, but that's fine.
I don't doubt it. I'm just trying to do the sort of simplest.
Yeah. Makes sense.
Let's write the tool get file, which is just this. If file return null. Okay.
Okay.
So this will just collect up all the text and make one giant text token or character token out of it.
Okay. So
I think we should be able to pass one of those tests from the test suite now.
well, from our own test suite, right? So you want, we didn't actually write the test, but you want this to just be a text node, or it's a body node with a text node in it?
What I wanted to do is I wanted to go back to, remember we were looking at the HTML5 lib tests? I wanted to find one of those tokenizer tests and see if our like incredibly dumb tokenizer is smart enough to pass any of them.
So the tokenizer tests all test the token stream. Is that what you want?
Yeah, so I think we're going to write a little test harness for the token stream. I think we try to write the tokenizer and the tree builder at the same time. We're going to be in sorry shape, and so I think we should try to just test the tokenizer as we go.
All right, so you want to pull down the HTML5, or you want to like write?
I just want to do one of them, just like do it by hand, and then try to do that by the end of the show, and then scaling up will be a later task. So like I expect there's one test in there that just parses a very simple text-only string.
You assume too much, but I'm looking. A lot of them are.
Do you want to project it? We could look together.
Yeah, I can project. There's one that has a question mark. Share. I found this true with Ren as well, that like the sort of bootstrapping tests are, they get lost in the mix later on. So just like looking for a character one, it's like this one is just a question mark.
But that's not like an entity. That's like a super complicated character one.
Yeah, well, I hear you. So here's.
Okay.
I mean, I could look for input colon. I don't see an empty one.
I see. Well, why don't we take the entity one and we can adapt it to be a basic text node.
This is the. Yeah. So here's just an ampersand.
Yeah, we can pass that one. We'll pass it because we're dumb. Later we'll have to pass it in a different way because we're smart.
Okay. All right. So you want to. Oh, yeah, so these are tree building tests, right? So
these are tree building
tests now.
Yeah. Do you want to switch back to code mode so people can see the code?
Oh, yeah. Sorry. Code mode.
Take me to code mode.
Okay. All right. So I think we should split this out, right? So these are. We should make a new test file, right? Which is tokenizer test.dart.
Okay.
Okay. And okay.
These are not going to be our DOM tests.
Did you rename it? Okay, great. So tokenizer test. So we want to do, how do we do this? We do var tokenizer is equal to tokenizer. We're going to need a helper function, right? We're going to want.
We can write the first one by hand.
Yeah, it's fine. So var input is equal to input manager. Which one? Ampersand. And then we want var doc equal to. No, this isn't doc. This is tokens. Tokenizer dot. Is this a like run to completion or?
We'll just get next token. That's fine.
So
We'll get
this
one
is
token.
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 Okay, and then we want to expect token.
I can run a helper that will get all the tokens here.
Is it text token or something? Token dot type. I don't know. Is instance of text. What does instance of want us to use? That's okay. Is a. Oh, okay, that's cool. Is a text. Okay, and then we want this. I actually don't know that I need to get them all at once, but
I made you a get token that returns you an iterable token.
this is the other thing is that as you start typing this out, you start to figure out how you want to hold it to write the tests.
Mhm.
Okay.
Okay.
That might press.
I don't know. We'll
Here's a
take
player.
the green dot.
Show me the green dot. I don't know what this button does.
It doesn't just run the tests constantly.
I don't know. There may be a way to like turn that on. I know such run. Whoa, what does that mean? Python dot. Whoa, okay. I do remember in previous times when editing these, this thing would get confused as to which things were which. Okay. Oh, interesting.
So
Does
kind
get
of
next
ELF.
not move the input stream forward?
Well, should we use the debugger since someone wanted to see the debugger?
What?
It's got a big debug button right there.
It does. I'm pressing it. We're going into the future.
Okay.
Okay. Maybe not.
So this
exactly.
thing is.
How do I show the debugger? Yep, this.
Oh, we need to set a breakpoint. It went all the way to the failure.
Well, I suspect this is also very straightforward, right? So when we do get next character, oh, it does move the offset forward.
Mm-hmm.
And what is EOAP? Next offset greater than or equal. Okay. Why don't we walk through it?
Okay. Do you want to set the breakpoint right at the top of get next function? Get next token?
Yeah, we can set it. Yeah, set it right here. Let's restart this. No, that's a hot reload, which is not what I want. Oh, maybe it did restart. We'll see. Okay.
Mm-hmm.
Hey, it stepped into something reasonable. Okay.
So char. Okay. Right.
Yep. Text buffer.
Okay.
Sure.
Continue.
Oh.
Oh.
Yeah. This is not what you want at all.
Good. You want while true, right?
Well, you.
Oh, we need to. Oh, I remember this. You have to do the same thing here. It's like a flush.
Well, I just don't think you. I don't think you're only ever returning one token. Oh, I see. But I mean, this is not what the data state says. You're writing a text buffer where the standard doesn't have one. Maybe you're just like you're remembering ahead of time. Like I do remember there's buffering, but if I just read the data state and you hit null, it says this is an unexpected null character parse error. Emit the current input character as character token. And so the current input character, I guess this is where you're staging it. Current input is the last character to have been consumed. Okay.
Yeah, this is the way the spec is written, but everyone who writes the parser does this because you want to make one text node. Let's try this. So should we rerun the test and see if this fixed it?
Okay. Where do we go? Tokenizer tests. You have such confidence. What did it say? Text. It's not instance of character token.
Oh, yeah, it's character token.
Okay, I have no idea what text is. Testing. I totally have Bruce Springsteen's Glory Days playing in the back of my head while we do this.
We spent an absurd amount of time making this thing actually correct for real.
It was great. It was a lot of fun.
I
We
don't
changed
trust
the world.
This green dot thing.
All right, we did not get a green dot. Oh,
Ah! Okay, I think we should declare victory for this episode. I think we made a lot of progress. We got sort of some basic structure in place, and now we just need to add all the other tokenizer states. No big deal.
no big deal. Well, there's some, yeah, I mean, okay, let me hide this for a second. I think there's some obvious things you do next. I mean, we're not quite teched up to write a parser for their JSON test suite and feed it into this. But that is a state you get to quickly, where you just take the test suite and you write a little runner for it, or you use their runner. I don't know. There may be a fancy runner at this point.
Yeah, I think the next thing that I would do probably is look for the angle bracket and like emit a tag token.
Yeah.
And then from there, probably now you're going to have more than one non-trivial test, and you're going to want to bootstrap into their test harness.
Yeah. And then you get to having a skipped list or needing a skipped list because not all the things you want to solve right away. And
yeah, that's why there's more stages in the Galaxy Brain thumbnail that we'll get to.
Anyways, this was fun, and we had a whole bunch of folks come and join us today, which is great. Any other thoughts before people return to their Thursdays or Fridays in some place at this point?
No, I think it's a great start. You're supposed to ask me about pizza because I actually made pizza yesterday.
You made pizza? I didn't make pizza this week. How's your pizza?
You know, I finally solved one of the problems. So we often make one of the pizzas with fresh mozzarella, and I've been having trouble that when you cook the fresh mozzarella on the pizza, it releases a lot of moisture. Yep. And so when the pizza is done cooking, it's like a lake full of like mozzarella and juice.
We had the same problem.
Well, it turns out we solved it by basically slicing the buffalo mozzarella pretty early and putting it on a plate, but on the rim of the plate, so that over time it would drain out its moisture into the bottom of the plate, and then it would be a lot less moisture when we put it on the pizza.
Yeah, I can see that.
I'm glad you enjoyed the variety. Like it's sort of I mean, it's all sort of focused around coding, but it's a sort of variety show for coding.
Something I never thought I'd say about what I do on Thursday nights. Oh, I do a variety show on coding. Anyways, I'm glad you had success. I may try your buffalo mozzarella around the plate, let it drain tip, because we had a lot of trouble with that. Actually, we're thinking we're going to get some different kinds of mozzarella next time we make pizza.
We just get it from Costco, so it's
sure,
pretty basic stuff.
Anyways, great to see you. Thanks all for coming and joining the party. Thanks all to those of you watching this tomorrow, and I'll see you next week.
Yeah, see you next week.